Hello and welcome to a new problem solving session. And you can see here a picture of a problem, and that means we are going to start solving problems related to magnetic field. This is also a problem related to calculation of magnetic field. I don't know whether we are going to use the Biot-Savart law or not, but let's read the statement of the problem first and then we will decide. And the problem is a current I flow along the contour ABCDA. You can easily look for it. This is the contour A, B, C, D and then A, back to A, formed by four edges of a cube, and it creates a magnetic field with induction B naught in the center of the cube. Okay, center of the cube, that is important, and its magnitude is B naught and the current involved is I. Find the magnitude and direction of the magnetic field induction vector B created at the center of the cube, okay, by the current I flowing along the contour of six edges, that is A, B, C, G, H, E, A, back to A, six edges. Okay, fine. So perhaps we are not going to use the Biot-Savart law in this case. What we need to solve this problem, the concepts needed to solve this problem are simply, you have to consider the symmetry of the problem itself and a bit of right-handed screw rule. So from symmetric considerations and the right-handed screw rule, it follows that the magnetic induction B naught created by this loop, this contour ABCDA is I guess along the y-axis, simply in this direction at the center of the cube. And now if I may suggest, I think you consider this six edge contour A, B, C, G, H, E, A. This six edge contour is the sum of three contours named A, B, C, D, A, and then I will consider the next contour simply as D, C, G, H, T, and the next in the similar manner as A, D, H, E, A. This is H, A, D, H, E, A. And now if you look closely, our contour A, B, C, D, A is containing this already present current A to B, B to C, and C to D is not present. And then D to A also not present. But when we start considering the next contour DC, that cancels out this current in this edge. It completely cancels out the current in this edge. DC, then GH, DC, then C to G. It has been taken into consideration. This is the part of the circuit. This current is the part of the circuit. And then GH, this is also the part of the circuit, and HD. This is alone, but it will be cancelled soon if we consider the current in this another contour, and this contour contains the current in A to D and you can see this cancelled out this current, and then D to H, and it also cancelled out this current, and it considers now EA, DH, HE has been taken under consideration, and then it also considered HE. So you can see that the current I flowing along the contour ABCGHEA can be represented as the sum of three currents I, of course I, flowing along the contours ABCDA, DCGHD and ADHA. And we know that each of these currents creates a field B naught at the center of the cube, and I would like to show a new picture to take considerations of these things more closely, and the picture is here. I have already drawn it, and if you can watch this closely, you can see here this our first contour. It has produced a magnetic field in this direction, A B C D A. This has produced current in this direction, and then you can see our contour D C G H D. It has produced a magnetic field in this direction, same magnetic field B naught, and our final contour, that is ADHEA, it has produced a magnetic field, same magnetic field B naught in this direction. So all three contours produce magnetic field of same magnitude in mutually perpendicular directions. So the net result I know is at the center of the cube, the magnetic field produced by the 6H contour is simply the vector sum of these three magnetic fields, and this is nothing but root 3 B naught, of course, and their direction will be something like along wave, and if you watch and solve this problem by yourself, you will get the direction easily. So it is in the direction wave and its magnitude is root 3 B naught, and the problem is solved. Thank you very much for watching.